Hi everyone, I'm Salmandu and welcome to YÖS ALFA. Are you preparing for the YÖS exam and looking for expert guidance? You're in the right place. In this video, we'll go through the complete solutions of the first trial exam from our YÖS ALFA exam preparation classes. Understanding the logic behind each question is key to success in the YÖS exam, and we're here to help you master it. Before you continue, the exam PDF is provided in the description down below. I encourage you to download it and try and solve it first before watching the solutions. This way you'll get the most out of this video. Don't forget to like, subscribe, and hit the notification bell so you never miss out our future YÖS practice and solution videos. Let's get started. Number 1. The numbers of elements of different sets are given, and the number of the elements of A intersection B intersection C is asked. So from set theory, we know that the number of the elements of A union B union C is the same as the number of the elements of A plus the number of the elements of B plus the number of the elements of C minus the number of the elements of A intersection B minus the number of the elements of B intersection C minus the number of the elements of A intersection C, and plus the number of the elements of A intersection B intersection C. Okay, the number of the elements of set A is given to be 20 and B is 15 and C is 20, and A intersection B is 5 and B intersection C is 8 and A intersection C 7, and let this be X. So the summation of 20 and 20 is 40, and it cancels out with 40 on the left hand side of the equation. And the number of the elements of B intersection C and A intersection C is 15, and this cancels out with 15 over here. So we're left with minus 5 plus X is equal to 0. And from here, X turns out to be 5. So the answer is D. Number 2. According to the given figure above, which of the following is the expression A intersection B the whole prime intersection B prime? So here, first of all, A intersection B the whole prime means not A intersection B or everything else except A and B. So we'll first start with A intersection B, which is nothing but C given here. So C prime is going to be not C or everything else except C. So we're going to have A, B, F, G, D, and E when we take C out of the universal set. So this is C prime, and B prime is going to be not B. In other words, everything else except B. So we'll take B out of the universal set and we're left with A, B, F, and G. So the question asks the intersection of the two sets. Since A, B, F, and G are common for both sets, we can take the intersection to be A, B, F, and G. So this is going to be our answer, A. Number 3, the function is given. What is f of 2? So we're asked to find the output of the function when the input is 2. So we first have to equate the input expression with 2. So x minus 1 is equal to 4x plus 6, so 3x is minus 7, and x is minus 7 over 3. When we plug this value into the output expression, we get our output as this one. 3 cancels out each other, and we get minus 8 over 4, which is minus 2. Number 4, given this, what is the sum of f of 0 plus f of minus 5? So f of 2x minus 1 is given as the piecewise function with x larger than minus 1 being minus 2x plus 4 and x less than minus 1 being 3x minus 2. So to calculate f of 0, we'll equate 0 with the input of the function. So 2x minus 1 is equal to 0, x is 1 over 2. So when x is 1 over 2, since it's larger than minus 1, we use the first function. So f of 0 is going to be minus 2 times, instead of x, we'll substitute 1 over 2 plus 4. Since these two cancel out each other, we have 3. So to calculate f of minus 5, since the input is minus 5, we'll substitute the input value into the input expression, 2x minus 1. From here, x is going to be minus 4 over 2, which is minus 2. Since x minus 2 is less than minus 1, we'll use the second function for f of minus 5. So 3 times x is minus 2 and then minus 2. This is minus 6. Minus 2 makes minus 8. So we're asked to find the summation of these two. So minus 8 plus 3 is minus 5. So the answer is A. Number 5. The graph of the function y is equal to f of x is given above. Given that f of x minus 1 plus a times f of x minus 2 is equal to f of x minus 4, what is the value of a? So before we continue, let me start writing down the known points. F of 3 is equal to 0 and f of 1 is equal to 0, and this point f of 0 is equal to 2. So I try to make use of this information, and if I assume that x is equal to 4, then I'll have f of 0 is equal to f of 2 times a plus f of 3. And f of 3 is known from the graph. F of 0 is also known. So if we somehow know f of 2, then we can find the value of a. So to find f of 2, we need to know the equation of the parabola. Since the 3 points are given, we can easily find the equation of the parabola. So f of x is equal to x minus the first x-intercept, which is 1, and then x minus another x-intercept times a constant. So that's the equation of the parabola. So how do we find b? We can find b from this point. F of 0 is equal to b times minus 1 times minus 3, and it is equal to 2. So from here, b is 2 over 3. So our equation for the parabola is complete now. So we can find f of 2 from this equation. So f of 2 is going to be 2 over 3, 1, minus 1. So it's minus 2 over 3. So I'll substitute this value into this equation here. So minus 2 over 3 times a plus f of 3 is 0, and f of 0 is 2. So from here, a is minus 3. So that's our answer. Number 6. The graph of the functions f of x and g of x are given above. Given this equation, what is the value of a? So I'm going to rewrite this equation this way. F circle dot g inverse of 1 is the same as f of g inverse of 1 plus g of a is equal to g inverse of minus 2. So from here, if y is equal to g of x, we can write g inverse of y is equal to x. So we're looking for g inverse of 1 and g inverse of minus 2. So g inverse of 1 is what? When y is 1 in the g graph, when y is equal to 1, what is x? In the g graph, when y is equal to 1, our x is 2. So we get this value. And then we also need to find g inverse of minus 2. G inverse of minus 2 is in the g graph, when y is equal to minus 2, what is x? In the g graph, when y is equal to minus 2, this is y is equal to minus, or x is minus 1. So g inverse of minus 2 is also known. Minus 1 plus g of a, and f of g inverse of 1 is 2. So to find f of 2, we come to the y is equal to f of x graph. When x is equal to 2 in this graph, what is y? When f is equal to 2, our y is 1. So it's 1. So g of a is minus 2. So from here, a is g inverse of minus 2. So g inverse of minus 2 has already been found, so it's minus 1. So that's our answer. Number 7. A, b, and c are negative integers. Given this, what is the maximum value of the sum a plus b plus c? To solve this kind of problem, it's always easier if we try to describe the summation as only one variable problem. To do that, I'm going to describe a, b, and c all in terms of c. So a is 5b plus 2. So b is given to be 7c plus 2. So 5, if I substitute b over here, it becomes 5 times 7c plus 6 plus 2. So 35c plus 30 plus 2 is 32. So that's for a. For b, it's already given to be 7c plus 6. For c, it's c. So the summation a plus b plus c is going to be the summation of these three. So 35 plus 7 plus 1 is 43, c plus 38. So we're asked to find the maximum value. And we know for sure that C is negative because A, B, C are all negative integers. So to maximize the sum, C has to be largest possible negative integer. So the largest possible negative integer is -1. So if you do that, the summation turns out to be -5. So that's our answer. Number 8. Given that x is an integer and x plus 7 the whole power 5 is an odd number, which of the following is an odd number? So x plus 7 the whole power 5 is an odd. It's given. So we know that an odd number raised to any power is also an odd number. And an even number raised to any power is also an even number. So from this statement, we can deduce that x plus 7 must also be an odd number. So to get this result, since 7 is an odd number, x must be an even number so that when we sum them up, we end up with an odd number. So we know for sure that x must be an even number. So let's check the answer choices one by one. So x is even, so x squared must also be an even number. So even plus even is another even number. So x cubed is also even number, times 5 is also another even, minus another even number will give us an even number. So x squared is an even number, plus an odd number will give us an odd number. So this is what we're looking for. Number 9, a and b are real numbers, and this is given, and that is given. What is the greatest integer value of the expression? So I try to change this expression to this one. A over 2ab plus b over ab. So a's cancel out each other and b's cancel out each other too. So the result is 1 over 2 1 over b plus 1 over a. So to get this result, I will try to write the expression 1 over a. So 1 over a is going to be between 3 and 6. So 1 over b from this expression is going to be between 2 and 8. So the summation of 1 over a plus 1 over b is going to be 3 plus 2 is 5 and 6 plus 8 is 14. So we're trying to maximize the sum because we are looking for the greatest value. So the maximum value of 1 over a plus 1 over b is 14. So half of 14 is 7. Number 10. This expression is given, and what is the value of the sum? So I will try to simplify this expression first by taking out the common factor 6. So what's left inside the bracket is 1 over 1 minus 3 to the x plus 1 over 1 minus 1 over 3. 6 times 1 over 1 minus 3 to the x plus, here we have common denominator, 3 to the x, 3 to the x minus 1 and 1. So it's 1 over 1 minus 3 to the x plus 3 to the x here at the numerator now. And 3 to the x minus 1 is here. So I'm going to multiply both numerator and denominators by -1 so that we have the same denominator. So it's going to be negative, and this one is going to be positive, and this one is negative. So the result is 1 minus 3 to the x at the denominator, and at the numerator you have the same thing. So the denominator and numerator cancels out, and our result is 6. 7. What is the result of the operation? So I will arrange in such a way that the summation between this number and that number is easier for me. So I can do that if I change 12.3 to 1.23 times 10 to the minus 3. So we have the same 10 to the minus 3 on both numbers. So now I can sum up these two. 1.23 plus 2.77 make 4 times 10 to the minus 3. So at the denominator, here we have 0.8. So if I make it 0.12 times 10 to the minus 5, then the summation is a lot easier. 0.88 plus 0.12 is 1. So the denominator summation is 10 to the minus 5 times 1, and at the numerator we 4 times 10 to the minus 3. So we have 10 to the 2 left at the denominator, so the result is 400. Number 12. What is the value of x that satisfies the condition? So this is the absolute value problem. We're going to test out two different cases for this and see which one checks with the solution given here. So x minus 2 can either be positive or negative. If it is positive, then we'll have this equation x minus 2 equals to x plus 4. When x cancel out, we know that minus 2 is never equals to 4, so this is impossible. We reject this case, so x minus 2 can never be positive. So how about negative? So if x minus 2 is negative, then when we take this out of the absolute value function, we multiply the expression by -1, so it becomes 2 minus x is equal to x plus 4. So 2x is equal to minus 2, x is equal to -1. So this is the only solution that is possible. Given this expression, what is the value of x? So we can change 9 to 3 squared and x plus 1. So when we take off the square root, we divide the power by 2, and we do the same thing on the right hand side of the equation. So when the cube root is coming off, we have x minus 1 over 3. So this 2 and that 2 cancel out each other. So we have the same base on both sides of the equation, so we can equate the respective powers. So x plus 1 is equal to x minus 1 over 3. So when we solve this equation, we have 2x is equal to minus 4, x is minus 2. Number 14. What is the result of the operation above? So we're going to start from the cube root. So minus 8 can be written minus 2 cubed. Since it is under the cube root, this 3 and that 3 cancel out each other. So we have -2, and there is another negative over here. So negative times negative is positive. So 7 plus 2 is 9, and 9 is under the square root. So this is going to be 3. So 4 minus 3 is 1. So square root of 1 is again 1. So 10 minus 1 is 9. So there is a square root above 9. So our answer is 3. Number 15. Given this expression, what is the difference between x squared minus y squared? Okay, these ratios are given. Let these ratios be k. So we have x plus 2y minus 3z. So I'm going to multiply with coefficients so that we have the same thing here. So x is x, and we have 2y. So I'm multiplying the numerator by 2. So I'm also going to do the same at the denominator. So here, minus 3z. So I'm also going to multiply the denominator by minus 3. So we have x plus 2y minus 3z, which is 16. So I am summing them up. So I'm also going to sum up the denominators. So 5 plus 8 minus 21. So the proportionality constant is not going to change if we do this operation. So 5 plus 8 is 13, minus 21 is minus 8. So k is minus 2, and we need x squared minus y squared. So x is 5k and y is 4k. So 25 minus 16k squared is our answer. So this is 9 and k squared is 4. So the answer is 36. Number 16. The interior angles of a triangle are inversely proportional to the numbers 1/3, 1/7, and 1/8. What is the sum of the smallest and largest angles of this triangle? So let the angles of the triangles be x, y, and z. So x is inversely proportional to 1/3. So that means this. Y is inversely proportional to 1/7. So we can write y is directly proportional to 7. And z is inversely proportional to 1/8. So we can write z is directly proportional to 8. So when we change this proportionality in the equation, we have x is equal to 3k and y is equal to 7k and z is equal to 8k. So this summation of the angles of the triangle gives us 180. So 3k plus 7k plus 8k is 18k is equal to 180. The summation of the interior angles of the triangle. So k is 10. So the question asks the summation of the smallest and largest angle. So the smallest angle is 3k and the largest angle is 8k. The summation is 11k. So k is 10. The result is going to be 110. Number 17. Given this expression, what is x? X over 2 is equal to 9. Since we have different denominators, I'm going to make it equal by multiplying both denominator and numerator by -1. So we have 3 minus x, and at the numerator we have -9. So plus x squared over 3 minus x. So since we have the same denominators, we can sum them up. So minus 9 plus x squared is equal to x over 2. So this is x squared minus 3 squared. So x plus 3 and x minus 3. So we have here x minus 3, negative 1. So they cancel out each other, and we have negative x is equal to 2x plus 6. So 3x is negative 6 and x is negative 2. So this is our answer. Number 18. Given this expression, what is the remainder when the polynomial p of x minus 3 is divided by x plus 2? So before we find this, we need to figure out what a is. So to find a, I'll substitute x is equal to minus 2. So this term will be 0. 0 times p of something is also 0. And since I am substituting x is equal to minus 2, so minus 2 the whole square is 4. 4 times 2 is 8. And this is 3 times minus 2 is minus 6 plus a. So you have a equals minus 2. So we got the polynomial. So p of x minus 3 divided by x plus 2. According to the remainder theorem, we equate x plus 2 with 0 to find the remainder. So x is negative 2. So when we put x is equal to negative 2 here, we have p of minus 5. So that's the remainder when p of x minus 3 is divided by x plus 2. So how do we find p of minus 5? Since this is known, so to find p of minus 5, all we have to do is just substitute in x is equal to minus 3 into the original equation. So p of minus 5 is going to be, there's going to be minus 3 plus 2, so there is minus 1. And I'm substituting x is equal to minus 3. So minus 3 the whole square is 9. 9 times 2 is 18. Minus 3 times 3 is minus 9. And a is minus 2. So that's my answer. So p of minus 5 is going to be 18 minus 9 is 9. 9 minus 2 is 7, since there is minus 1. So our answer is negative 7. 19. ABCD and KLMN are rectangle, and the side lengths are given. AB is x plus 3, BC is 2x minus 1, and KL is x plus 1, and LM is 2x minus 3. So what is the shaded area? To find the shaded area, all you have to do is just subtract the smaller area from the bigger area. So the bigger area is 2x minus 1 times x plus 3, minus the smaller area is x plus 1 times 2x minus 3. So we're going to multiply the 2x times x is, I'm going to write it down here, 2x squared plus 6x minus 3. Over here is 2x squared minus 3x plus 2x minus 3. So when we simplify them, we have positive, negative, positive. These two cancel out each other. Okay, this is 6x minus x, 5x, and then 3x and 3x. So we're left with 6x. And there is negative 3 and positive 3. They cancel out each other, so we're left with 6x only. So the answer is C. 20. The function f is defined from 2 to 6. And f of x is x squared minus 6x plus 7. So that's a parabola, concave upward. And what is the sum of the different integer values that the function can take? So f of x is y. So we're asked to find all the possible y values. So how do we find all possible y values? So that y possible values should be between y minimum and y maximum. To find a y minimum, we know that we can find f of minus b over 2a to find y minimum, which is f of 6 over 2, which is f of 3. So f of 3 is 9 minus 18 plus 7, which is minus 2. So our y minimum is minus 2. How do we find y maximum? Y maximum between this range is f of 6. F of 6 is equal to 36 minus 36 plus 7, which is 7. So our possible different integer values are between this range, minus 2 to 7. And we're asked to find the sum of those different values. So all we have to do is sigma y is equal to minus 2 plus minus 1 plus 0, 1, 2, up until 7. So minus 2, minus 1, 1, 2, they cancel out each other. So we can find the sum from 3 to 7. 6, 4 is 10, 7, 3 is 10, and plus 5 is 25. So our sigma y is 25. Number 21. The second order equation is given. What is the value of the expression x squared plus 16 over x squared. So from here we understand that it is asking x squared plus 4 over x the whole square. So can we somehow manipulate this equation so that we have 4 over x? Yes, we can. If we divide both sides of the equation by x, then we have x plus 2 minus 4 over x is equal to 0. So when we subtract 2 from both sides, we have this, and squaring this expression will give us this. So this is our answer. X squared plus 16 over x squared is 12. The answer is E. Number 22. Two equations are given. What is the value of a to the 4 plus b to the 4? So we'll start by squaring both sides of the equation. So we get a squared plus b squared plus 2ab is equal to 4. ab is given to be negative 3. So we have this term negative 6. So a squared plus b squared is 10. So we are asked to find a to the 4 plus b to the 4. So we'll square our answer one more time again. So we get a to the 4 plus b to the 4 plus 2 times a squared b squared is equal to 100. So ab is negative 3. So negative 3 the whole square is 9. 9 times 2 is 18. So a to the 4 plus b to the 4 is 100 minus 18, which is 82. Number 23. In the graph above, parabola f of x and linear function g of x are given. What's the value of g of f of 3? So we'll first find f of 3 from the given graph. So the parabola is given and the 3 points of the parabola are known. So we can write down the equation of that parabola as x minus the first intercept of x-axis and x minus the second intercept of the parabola and the constant. We can find the constant from this point. Minus 1 is f of 0. So f of 0 is equal to b times minus 1 and 1, negative 1. So b is 1. So our f of x is going to be x minus 1 times x plus 1. So we are looking for f of 3. So f of 3 is 3 minus 1 times 3 plus 1. So it's 8. So our second target is g of 8. So the g function is also given as a linear line. So there are two ways to find g of 8. The first way is you can write down the equation of the linear line. Since the 2 points are given, you can easily find it. But I'm going to use the similarity of the triangle. Let's say this is 8. So I use this triangle. These two triangles are similar. So we can take the ratio of the corresponding side. This side is 7 and this side is 1. This side is also 1. This is what we're looking for. So y over 1 is equal to 7 over 1. So our answer is 7. Number 24. In the equation above, which of the following is the value of y in terms of x? So we're asked to find y in terms of x. So I'll use the identity a cubed minus b cubed is equal to a minus b a squared plus b squared plus ab. So here it's the same. 1 over x cubed minus 1 over y cubed. So I can follow this formula. So 1 over x minus 1 over y, 1 over x squared plus 1 over y squared plus 1 over x y. On the right hand side of the equation we have 1 over x squared plus 1 over xy plus 1 over y squared, and I can factorize this as 1 over x plus 1 over y and 1 over x minus 1 over y. So this term cancels out with this term and this term cancels out with this one. So we're left with 1 over x plus 1 over y is equal to 1. So we want to find y in terms of x. So I'm gonna keep the y on one side of the equation. I'll send x to the other side. So we have this x minus 1 over x is equal to 1 over y. From here we get y is equal to x over x minus 1. The answer is E. Number 25. The solution set of the equation is minus 1 and 2. Given this, what is the value of m plus n? So from the solution set, we can write down the second order equation like this. From here, we can multiply the 2 and get x squared minus 2x plus x minus 2 is equal to 0. X squared minus x minus 2 is equal to 0. Now we can make the comparison between the equation given and what we got here. So n is negative 2. Here, the coefficient of x is negative 1. Over here, it is m plus 1. these two must be equal. So from here, we get m is equal to minus 2. So since we asked to find the m plus n, the answer must be negative 4. Number 26. Which of the following is the solution set of the equation? We'll start by taking the squares of both sides. So we get 2 plus square root of 3 plus x minus 2 times square root of 1 minus x is equal to 4. So 4 minus 2 is 2. Squaring both sides of the equation, we have this. 4 minus 3 is 1. Rearranging this equation, we have x minus 1 is equal to 2 square root of 1 minus x. Squaring both sides, we have x squared plus 1 minus 2x is equal to 4 times 1 minus x. So 4 minus 4x is equal to x squared minus 2x plus 1. From here, we have x squared plus 2x minus 3 is equal to 0. So we have x is equal to minus 3 or x is equal to 1. So let's substitute back this result to the original equation, starting with x is equal to 1. Then we have 2 plus 3 plus 1 minus 2, 1 minus 1, and so we have this. So this is 0. 3 plus 1 is 4. Taking out of the root, it becomes 2. 2 plus 2 is 4. So our answer is 2. So it agrees with the given equation. So when x is equal to negative 3, so we have 2 plus 3 minus 3 minus 2 square root of 1 minus 3. So we have this result. So here, this is 4. Taking out of the root, it becomes 2. 2 times 2 is 4. It's negative 4. And these terms cancel out each other. So you have 2 plus square root of negative 4. So this is not a real number. So you can't simplify further anymore from this step. So this is not our answer, because it doesn't give us 2. So our only answer will be x is equal to 1. 7. The right triangle is given. Let's say BCA is x, then BAC is 3x. And we're asked to find the ratio of AB and BC, this one and that one. So I'm going to start with drawing a line from A to BC in such a way that the angle A is divided into x and 2x. So now we have an isosceles triangle here, having this and this side the same. Since this is x and that is x, we also know that this one must be 2x. Now we also have another isosceles triangle having these two sides the same. Now let's assume that AB is y, so BD must also be y, and the hypotenuse must be root 2y from the Pythagoras theorem. Since this is root 2y, this must also be root 2y. Now we can write the ratio of AB and BC. Y over y plus root 2y. Simplifying this, we have 1 over 1 plus root 2. Multiplying both denominators and numerator by 1 minus root 2, we have root 2 minus 1 as the answer. Number 28. This is given. And then the angle ADB is 45 and BC is root 2. So we're asked to find the ratio of this. So we'll start from the area of triangle ABC so that we have AB times AC. So I'll take this AC as the base of the triangle ABC. So the area would be half times base times the height AB. So I have AB times AC. If I can somehow relate this area with the length AD, then we can have the solution. So let's try and relate this by drawing a perpendicular line from A to BC. This is the height of the triangle, and since this is 45, this is also 45. So this is 45, 45, 90 triangle. So the length of the hypotenuse is root 2h. So the area of the triangle ABC, if I take BC as the base of the triangle, then I can write half base and then height. So BC is nothing but root 2 here. So root 2h turns out to be AD. So we can write half AD is equal to half AC times AB. This and that cancelled out. So we have AD over AC times AB is equal to 1. So B is the answer. Number 29. In the triangle ABC, these lengths are given and DC is out. So these two are equal. So we have an isosceles triangle here. So we're going to draw a perpendicular line from C to the base of the isosceles triangle ABC. So it divides the base into two equal parts. So the entire base is 12 plus 6, which is 18. So half of which is 9. So this part, 6 is already there. So we have 3 over here. So this is the right triangle. So 9 is 3 times 3. 15 is 3 times 5. So we have 3 times square root of 3 square. 5 square minus 3 square. So which is 4. So this is 12. So we have 3 times 4 over here and 3 times 1 over here. So this is 3 times square root of 4 square plus 1 square is 17. So the answer is B. 30. DE and BC are parallel, and we have two perpendiculars, and DAC is 130, and BF is a bisector here. Angle BFA is that. So let's draw a line parallel to both DE and BC crossing A. So since this is 90, this is also 90. So we have 40 over here. So this is 90. If this is 40, this has to be 50. And since this blue line and the green lines are parallel, we have a zigzag going on here. So if this is 50, this is also 50. So since this is a bisector, BF is a bisector, we have 25 on each side of the BF. So since this is 25 and that is 90, theta is 65. 31. ABCD is a quadrilateral. AB is perpendicular to BC. BC is equal to AD. Alpha is that. So we'll start with drawing a perpendicular line from D to AB, and we'll name the intersection point. So we have a special triangle with 30, 90, and 60 degrees. If the opposite side of the 30 degrees angle is x, then we know that the hypotenuse is, if AD is 2x, then BC is also 2x. Now let's construct another line, another perpendicular line from D to BC, and let's name it F. If ED is x, then BF is also x, because these two sides are parallel and this is perpendicular. If BF is x, then FC is also x, because the entire length of BC is 2x. So we can see that in the triangle BDC, the F is both median and height at the same time. And we know that whenever we have the two auxiliary elements of a triangle equal, then we have an isosceles triangle. If the angle C is 75, the angle B is also 75. The summation of these two is 150, so alpha must be 30 degrees. So the answer is 32. OABC is a square, and point B is given to be 315. The area of this shaded region is asked. So we'll start with drawing a perpendicular line from C to DO, and let's name it E. So let's say this is theta and that's alpha, and we'll use this triangle throughout the sides of the square. So we also have this triangle over here and another triangle over here. Let me draw this line too. So theta plus alpha is 90. Since this is a square, so that's also 90. So if this is alpha, that's theta. This is also 90. So this is theta, then that's alpha. This is theta. This is 90, so that must be alpha. If this is alpha, this is also theta. Okay. And these three triangles are similar because they have theta and alpha, and they have also one equal length. So we can say that they're all congruent to each other. So let's say the opposite side of alpha is x and the opposite side of theta is y. So here we have the same, since they are all congruent, we have the same sides too. The opposite side of alpha is x, the opposite side of theta is y, the opposite side of theta is y, the opposite side of alpha is x. So now this length is nothing but the y coordinate of point B. So we can write down x plus y is equal to 15. And this length over here is 3. So 3 plus x is the same as y. Plugging in y into the first equation, we have x plus 3 plus x is equal to 15. From here we have 2x is equal to 12 and x is 6. If x is 6, then y has to be 9. So can we find the area of this triangle now? So we know the height of the triangle. So this is 6. Let me use a different color. So y is also known. Y is 9. If you know this length, then we can find the area of this triangle. So let's say this length DE is A. So to find A, we can use Euclid theorem. 6 squared is equal to 9 times A. From here we have A is equal to 4. Thus the area of the triangle is half times the base is 9 plus 4. And the height of that triangle is 6. So we have 13 times 3 is equal to 39. So the answer is B. 33. AOBC is a rectangle. An equation of line D is given to be this. And the perimeter of AOBC is asked. Let's say AO is A and OB is B. So the perimeter of AOBC is 2 times A plus B. And the coordinate of point C is minus A, B. Substituting point C into the equation, we have minus A over 6 minus B over 6 is equal to minus 1. From here, we have A plus B is equal to 6. What we want is twice A plus B, so the answer is going to be 12. 34. ABCDE is a regular pentagon, and DH is equal to FL, and DF is equal to FC. It's already given here. FKL are collinear. The angle FLA is asked. So in a regular pentagon, we know that the height is equal no matter from which vertex we draw it. So we'll construct another height from the vertex A. So DH is the height of the regular pentagon, and so is the AF. So now we have AF is equal to FL. So AFL is an isosceles triangle. So if this is theta, this must also be theta. Since the height is also the bisector at the same time, we do have another theta here. We also know that in a regular pentagon, each angle has 108 degrees. So from here we have 2 theta is equal to 108. So theta must be 54. So the answer is D. 35. In triangle ABC, AD, BD, and DC are equal. So these lines are equal. And the angle BAH is 20. It's already given here. And angle DAC is asked. X is asked. So we have the perfect triple situation here. And we know that this angle is 90. And since this is an isosceles triangle, we have, if this is X, we also have another X here. If this is 20 and this is 90, so angle B must be 70. So in the triangle ABC, so this is 70, this is 90. So we know that X must be 20. So the answer is D. 36. In triangle ABC, AD is equal to 3BD. If AD is 3A, then BD is A. In the same way, AE is equal to 3EC. If AE is 3B, then EC is B. And the ratio of the area ratio of ADPE and ABC is asked. So let's construct a line from A to P. Now we have 4 triangles. There are 2 on the right hand side, there are 2 on the left hand side. And the triangle ADP and BDP has a common height here. If they have the common height, then we can write down their area ratio as the ratio of their bases. So if this is A, then the area of ADP is 3A. In the same way, on the right hand side, we have 2 triangles having the same height here. So we can take their area ratios as their basis ratio. So if this area is B, then the area APE is 3B. Now we can write down the ratio, the area ratio of those triangles. For ADPE, we have 3A and 3B. For ABC, we have 4A and 4B. When we simplify it, we have 3 over 4 as the area ratio. The answer is C. 37. 2 circles are tangent at point C, and AC is equal to 3BC. If BC is A, so AC is 3A. And we have a formula of the relation between S2 and S1, which is S2 over S2 plus S1 is equal to A over 3A, and the whole square, which is equal to 1 over 9. So from here, we can derive S2 over S1. So 9S2 is equal to S2 plus S1. So 8S2 is equal to S1. S2 over S1 is 1 over 8. So the answer is A. 38. ABCD is a square and BCF is an equilateral triangle. Since this is square, all the sides are equal. And BCF is an equilateral triangle. All the sides are equal here too. So we'll start from equilateral triangle. It has 60 degrees for all angles. So if this is 60, that's 90. And since DC and FC are equal, we have this angle 75 and that angle 75 over here. So if this is 60 and that's 30, and this is 135, so this angle is 45. 30 plus 45 is 75, so x is 105. 39. ABCD is a rectangular shape given, and AEFD is a deltoid, and the ratio of AE and EB is as. Since AEFD is a deltoid, EF is equal to AE, so this side length is 2. Let's say this is theta, and that is alpha. Since this is 90, theta plus alpha is 90. Since this is a rectangular shape, so if this is alpha, this is theta, and this is 90, this should be alpha. So now we have two similar triangles, DFC and CBE. If we can somehow show that their corresponding side ratio is 1, then we'll have two congruent triangles. In fact, DF over CB is equal to 1 because AD is the same as BC and DF is the same as CB. So the ratio of DF and CB is 1. So these two triangles are congruent. So the opposite side of theta is 3 over here. So the opposite side of theta over here must be 3, 2. So we have the ratio of AE and EB as 2 over 3. So the answer is D. 40. In the triangle ABC, this 90 is given and the two perpendicular sides are given here and there. FG3, GEEH is equal to 4, HC is 12, so everything is complete. So the area of rectangle BDEF is asked. So to find the area of this rectangle, we should know A and B. So from the triangle FGE, from the Pythagoras theorem, this is 3, that's 4, so A must be 5. And this is 90 because this is a rectangle. So from the Euclid theorem, 12 times 4 is, let's say this is C squared, which is 48. So using the Pythagoras theorem for the triangle DEH, so 48 plus 4 square root is B. So it's 64, so B is 8. So the area of this rectangle is 8 times 5, which is 40. Number 1. This is a number figure relation problem. The relation here is this. 9 plus 7 is 16. Half of this is the one in the middle, it's 8. So we can check the formula here too. 7 plus 13 over 2 is 10, so it checks out. Well, so for this, you can write the relation this way. 9 plus, let's say this is x. X over 2 is 15, so x is 30 minus 9, it's 21. Number 2, how many cubes are there in a figure? So we're supposed to count the cubes. There are different ways of counting these cubes. You can start from top to bottom, from bottom to top, from left to right, from right to left. Doesn't matter. We're going to start from bottom to top, layer by layer. So let me start with this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5 times 6, I will put this cube over here. And there are a few cubes that I didn't count. 1, 2, 3. So plus 3. So it's 33 at the bottom layer. And then I'll keep on counting the second layer from the bottom. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 times 5 plus the 3 cubes at the back. So it's 23. And I put this cube over here, and then I'll do the same procedure. 1, 2, 3. 1, 2, 3, 4, 5. 3 times 5. And there's one more cube over here. 16. And then for the top layer, I'll just count them one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10. And then I'll add them up. So it's 82 altogether. Speed. Number 3, the x values and y values are given. And we're asked to find one x and one y. So we'll start with what's known. So 60 and 65, we'll try to make an operation out of it. So 60 and 65, I'll subtract them. And x minus y is going to be negative 5 and 7 and 11. This number seems to be following a pattern here. 5, 7, 9, 11. So this should be 3. So 3, 5, 7, 9, 11. And I assume that this negative is going alternatively here. So this is negative 9. So to have negative 9, x minus y, this number should be 99. And to have 3 for x minus y, this number should be 20. So do you have such numbers in the answer choices? Yeah, there is 20 and 99. Number 4. In this problem, there are 3 operations given. The circle operation, the square operation, and the diamond operation. In the circle operation, the 2 squares on the sides are out in this arrow direction. In the square operation, the square on top is out in this arrow direction. In the diamond operation, the square at the bottom is out in this arrow direction. So to get this figure, what kind of operations should we go through? So the 2 pieces given on the sides are out. That means we have the circle operation here, and the piece at the top is out in this arrow direction. That means we have the square operation here. So the answer should be circle and square. This is C. Number 5, the figure matrix is given here, and there's a pattern as we go from left to right. The first one is reflected along this axis, so you get this one over here. And the second one is rotated 90 degrees clockwise. So when you rotate this 90 degree clockwise, you get this shape. And when you combine the rotated version and the original version, you get this as a result. We keep following the same pattern for the second row. So reflection along this axis will give us second one. And rotation 90 degree clockwise will give us this one. So this is the result. For the third row, let's do the procedure. Reflection about this axis will give us this. The only difference between the 2 rows up there and then the third one is that we are reflecting the white ones instead of the green one. So to get the third figure, we rotate 90 degrees to the second one. So we get that with 4 whites given here and the green in the middle. This is A. Number 6. This is a password problem. So there are different ways of solving this kind of problem. I'll just use the column chat. I think this is the easiest one. So when we take a look at the last column, there are 2 E's and there are 2 A's. So when we take a look at the column on the right hand side, the last column is given here. So there should be 2 pairs. So this is the first pair, this is the second pair. I don't need to know which one is E or which one is A. I just need to know that there are 2 pairs. So now what's left when we eliminate the pairings is this. So this must be A as A D. So D E as A is asked. So A is right arrow, S is down arrow. So do you have any choices here? Right and down. So this one. That's the only choice with right and down. So the answer is D. Number 7. This is the number figure relation problem again. So we're supposed to find the relations between them. To get 21, we multiply 7 and 3. To get 18, we multiply 6 and 3. So that means to get X, we should multiply 5 and 6, 30. And to get 54, we multiply 9 by 6. So we're left with Z only. To get Z, there should be another operation. Okay, let's take a look at this. 5 plus 6 is 11. 6 plus 3 is 9. 3 plus 7 is 10. That means there is an addition relation here. So 5 plus 9 should be 18. The summation is asked here. X is 6, X is 30, Y is 6, and Z is 14. When we sum them up, 14, 6 is 20, plus 30 is 50. So the answer is D. Number 8. The paper is folded according to the arrow direction and cut along the red line. Which of the following is the unfolded version after the cut? So the unfolded version is asked. To solve this kind of problem, the easiest way is this. We reverse the direction of the arrow. First step is this. The second step is this. So when we unfold it in this arrow direction, we get this. When we unfold it upward direction, we get this shape. So the answer is B. Number 9. This is a number-figure relation again. So we'll try to get 17 as the answer by using the numbers given around it. 18 plus 27 plus 13 plus 10. How much is it? 27, 13 is 40, 50, 68. So 68 divided by 4 is 17. So we'll try to use this relation again here to find t. So 10 plus 20 plus 13 plus 29 is 30, 40, 60, 72. Divided by 4 is 18. So our answer is A. Number 10. This is a reflection type of problem. So the given shape, this one, is reflected about this axis. So we get this figure as a result. So what's going to happen if we do the same procedure for the one given here? I'm going to draw this one for you. So we're going to reflect this figure about the blue line. You get something like go down a bit to the right, go up a little bit to the right again, go down all the way here, and then a little bit to the right, and goes back down. This is the figure that we're going to get. So the answer is B. Number 11. The unfolded version of the dice is given, and the folded version is asked. So we check this one by one. So 2, 3, 5. Since 2, 3 is given here, we're going to fix this 2 and 3 here. So 1 is on the left side of the 3, so there's 1, and 4 should be at the back, and 6 should be on the bottom, and 5 is on the right surface. So 2, 3, 5, here is also 2, 3, 5, so that's a correct answer. There is also another trick that you can make use of in this kind of problem, and that is to first write down the sides that are on the opposite side of the dice. For example, 4 and 3, they are 1 square apart. That means they can only be on the opposite side of each other. So I'm going to write it down. 3 and 4, opposite sides. And same is true for 1 and 5. They are on the opposite side of each other because they are 1 square apart. And what's left? 2 and 6 must also be on the opposite side of each other. So knowing this, it's a lot easier for us to decide which one is impossible. For example, let's take a look at this. 1, 3, 5. Since 1, 5 is next to each other, it's impossible because 1 and 5, we know that 1 and 5 must be on opposite side of the dice. So let's check C. 1, 6, 2, 6 and 6, 2. They can never come next to each other because they are on opposite side of each other. So this is also impossible. 1, 5, 4. and we know that 1 and 5 can never come adjacent to each other. So this is also impossible. So 1, 5 is same problem. 1 and 5, they can only be on opposite sides of the dice, so it's impossible. So when we eliminate the 4 choices, we're left with the only possible choice, which is A. Number 12, number figure relation. The relation here is 4 plus 7 plus 9 is 20. So the summation of these 3 numbers is the same as the multiplication of these 2. So we check this here. Summation is 28. The multiplication is, summation is 18 and the multiplication is 18 too. So the summation of these 3 is 12. So 3 times 4 is 12. 4 is the answer. 13. So the shaded area is asked. The easiest way to find a shaded area is to divide this big area into smaller pieces and then sum them up. So I'm going to divide them into smaller rectangular pieces and then I'll sum them up. You can do it as you like, but I'll do this. This is 6 times 1 is 6, and 2 times 1 is 2, and x, so that's x, that's x. There is 2x left since the whole thing is 4. X is 3x, so that's also 3x. 3 times 1 is 3. 2 times 1, the whole thing is 4, so this one is x, so this is 3. 3 times 1 is 3. So when we sum them up, 8, 11, C is the correct. Number 14. This is a figure series with a certain pattern. We're supposed to find that pattern. So the rotation of the first figure, 90-degree clockwise, is the second one. And the 90-degree clockwise rotation of the second one is the third one. And then we can see that the green color is coming on and off. Here it's off and coming back on again. So on the fourth one, it's supposed to be off. So 90-degree rotation and the green color is off. So the answer is number 15. This is a mapping problem. We're going to map out the correct pairing. So to start with this, I'm going to start by writing down the branch. Starting from F, there's 1 branch. Starting from A, there's 3. Starting from E, 3, and then 2, 2, 3. So I'm going to keep doing the same stuff on the right-hand side too. So there's 1, 3, 3, 2, 2, and 3. So the rest is just matching them. One branch is, there's only one ladder with one branch, so which is F. I will write down F here, and then connecting with F is and F done, E done, and then there are two branches. There are two circles with three branches left with three. Okay, D and A, either D or A. This is also either D or A. So what's left? It's only B and C left. C, B, C. So what is asked is XY. So XY is BC or CB. Let's see. I mean, if okay, let's check the answers. If there is only BC, then we can just select this as the answer. Unfortunately, there are both BC and CB. So we just have to come back and check which one is B and which one is C. So, okay, between X and Y, only Y is connected with E. So the one that is connected with E must be what? Connecting with E must be B. So this is B. So that has to be C. So XY is C, B. The correct answer is E. Number 16, the multiplication table is given. So I'm going to write down the equations given here. AB equals 54, AC is 36, and BC is 8 over 3. So there are two A's, two B's, and two C's. So when we multiply them, we're going to get ABC, the whole square, equals 54 times 36 times 8 over. So we want to find B, so we're going to eliminate AC. So AC is here. It's given to be 36. So 36 times B, the whole square. Okay, I'm going to write it this way. B is square root of 54 times 12 times 8. So B is going to be square root of 54, 12, 8 divided by 36, 9 times 4, 6, 3 times 2, 2. So 4. So 4, that's 2. So 2 is the answer. Number 17. To solve this kind of problem, the easiest way is to start by checking the answer choices A, B, C, D, and E. So let's see. They all are similar in that they have these lines in the middle, so I don't have to check this out. I will focus on the differences between them. So the difference here is it has got this one. We don't have this one here. We have this line here. So let's check if we have this line or not. So we have the line between the first dot and the second dot, but we don't have the line between the second dot and the third dot. Here we have the line between second dot and third dot. That means we must have the line between second dot and third dot. So we can eliminate this, and we can also eliminate this. So we are left with three choices. And what are the differences between the three choices left? So let's see, C and E. Okay, E has got this one. So we'll see. Let's check if this one is there. Okay, this line is that line given here. So we already have this line given here, so we're not supposed to have this line again. So we can eliminate choice E. And what's left is choice A and C. So what's the difference between them? The only difference between them is A has this line connecting this. C doesn't. So do you have it? Okay, this line is there. Again, over here, we've got this line, so we can eliminate A too. So we're left with C only. So that must be the correct answer. Number 18, the figure matrix is given. We need to find a pattern. So going from left to right, this is a reflection about the vertical axis. So going from left to right, this is the reflection about the vertical axis. This is also the reflection about the vertical axis. Going from the second figure to the third one is 180-degree rotation clockwise. So here it's the same. So it's going to be this shape. So the answer is D. Number 19. This is again the figure matrix problem. So we're supposed to find a pattern here. So the pattern is the summation of the first two gives us the third one. So for this one, the answer is going to be summation of this and that gives us this. So okay, the last one is asked. So I'm gonna copy this to here. So the answer is this one. So it's C. Number 20. The perimeter of the figure is asked. So the height and the lengths are given. So the length is 6a, so which means you can consider this as a continuous line from left to right. So this is 6a. So that is another 6a we have here. So 6 plus 6. And then the height is 5a. So this is 5. And this is another 5. So we have two 5s. And what's left is 2a and 2a. So this is 4a. So the summation is the perimeter of the figure. So 12, 10, 22, and then 426 is our answer. Number 21. So the figure relation is given from 1 to 4 and we're asked to find the one on the 5. So going from left to right, this circle, the two circles are going down one step at a time. So the two circles should be here. And the two circles at the bottom, they're going up one step at a time. So the rest of the figures are just the stars as given. So the answer would be E. Number 22. How many cubes are there in the figure? So 1, 2, 3, 1, 2, 3, 4, 3 times 4, and then 1, 2, 3, 4, 5, 6. So the answer is 18. Number 23. It's again number figure relation problem. So this is the result. To get this result, you can multiply this two and that two and sum them up. So 5 times 7 is 35. 6 times 3 is 18. The summation is 53. So 9 times 2 is 18. And 6 times 4 is 24. The result is 42. Number 24. This is a missing puzzle piece problem. So this is one of the problems where starting from the given answer choices is a lot easier. So let me zoom out a little bit so that we can see all the answer choices given. So let's take a look at the similarities and differences between the given answer choices. So let's start with this. So we don't have the same pattern over here. Okay, C, D, E are the same and A and B are different. So let's take a look at this. So it's not rounding over here. So answer choice A is eliminated. It's not that sharp over here too. So B is eliminated. So we're left with C, D, and E. So what are the differences between those three choices? Let me check. Okay, this part is a little bit different. This is a little bit long over here. This is not that long, and that is pointy. So we don't have that sharp edge over here. So E is eliminated. So we're left with only C and D. So D is the correct choice here. So it's always easier to start from the given answer choices because you don't have to check every step of the way if you start from the answer. And you can get to the answer straight away. Number 25. So this is a mapping problem, just like the one we had before in this test. So we're going to start with counting the branches. 2, 1, 1, 2, 1, 2, 3. So this is 1, 2, 2, 1, and there is 1. So this is 3 branches. Okay, there's only one letter with 3 branches. So it's B. So Y is B. So connecting with B and having only one branch is which one? Connecting with B and having only one branch, these two have 2 branches, and that one is the one we're looking for. So this is D. So our answer is DB. So it's A. Number 26, the multiplication table is given here. So I'm going to write down the equations. AB is equal to 16C, and AC is B, and BC is 144A. So when we multiply these 3 equations, we have 2 A's, 2 B's, and 2 C's. So ABC, the whole square, is equal to 16 times C times B times 144A. So we have 1 A, B, and C here, so it's going to cancel out with one of the ABCs on the left-hand side of the equation, and we're left with ABC is equal to 16 times 144. So plugging in AB is equal to 16C into this expression, we have 16C squared is equal to 16 times 144. From here, 16 cancel out each other, so we are left with C is equal to 12. So plugging in AC is equal to B into this expression, B squared is equal to 16 times 144. So B is going to be 4 times 12, which is 48. So plugging in BC is equal to 144A into this expression again, we have 144 A squared is equal to 16 times 144. So these cancel out each other. So A is going to be 4. So we have A, B, and C now. So the summation of those 3 gives us 64. Taking the square root of this is 8. So this is the answer. Number 27. The figure matrix is given. and the missing piece is S. So we need to know the pattern here. So going from top to bottom, so we rotate this one 90-degree clockwise to get the second one. So we rotate the second one 90 degrees counterclockwise again to get this. So this 90-degree clockwise and 90 degrees counterclockwise, they cancel out each other and you get the same result as before. So here in this one, the first one and the third one is also the same. So here in this one is also going to be the same. So the answer is the same as this one. So it's B. Number 28. It's a password problem again. So we're going to use the column check just like before. I'll start with the last column. So in the last column, there are 2 digits that are repeating. So in the last column, there should be repeating number. So repeating letter. So in fact, it's T. So T has to be 9. So T is 9. So our answer should be ending with T. So there are only 2 choices that are ending with T. So T is 9. So we have one password starting with 9. So there should be something on the right-hand side which is starting with T. So this is 98672. So I'm going to write it down. 98672. So 8 is A. So our answer should start with A and end with T. So the answer is B. Number 29. In the above sequence of figures, which numbers should replace K and L? So there is a sequence of number. We need to find out what the sequence is. So the multiplication of 2 and 1 is 2. The multiplication of 4 and 3 is 12. So that's a multiplication sequence. So I'm going to write down this. So 2 and 1 is 2. 4 times 3 is 12. It's given here. And the result is 10. So K should be 5. 5 times 2 is 10. So 4 times 3 is 12. So this one should be L is 12. We can keep writing this relation here, but it's not asked. So we don't need to, but just so you know, 10 times 5 is 50. So L is 12. 12 times 6 is 72. So everything checks out. So the answer is 5 and 12, E. Number 30, it's a number figure relation again. So this is the result. Okay, all these are the result. To get 22, I sum these numbers up. 6, 4 is 10, 7, 5 is 12. So the summation is 22. Here again, 5, 2 is 7, 4, 1 is 5. So the result is 12. So here, 9, 2 is 11, and then 8, 1 is 9. So our Y summation is 20. Number 31. The unfolded version of the cube is given and the folded version is asked. So as usual, we're going to start writing the opposite sides of the cubes. Let's start with this. So the star is in the middle, and the star and the rectangular shape, the square shape, whatever that is, since they are 1 square apart, they should be on the opposite sides of the cube. And the same is true for the star and that. They should be on the opposite sides. And what's left is this circle and the black square. So they can never come next to each other. So that's the trick we should focus on. So here, these two are coming next to each other. They can't because they are on the opposite sides of the cube. So this is impossible. The same thing again, the same thing again. So we can cancel them out. And we have the same thing here. They are coming next to each other. So it's impossible. So our only possible choice is D. Number 32. So the shape given is the intersection of the 3 shapes over here. So what's the intersection of these 3 shapes given here too? So it must be here. So it's C. Number 33. In the above sequence of figures, which number should replace K and L? So there is a sequence in the figure. So we need to find that sequence. So 4 times 3 is 12. So it's a multiplication sequence. 5 times 2 should be 10. Okay, I'll assume that and I'll check with the other numbers given. So this is 12 and 4 times 2 is 8. So far everything checks out. So 6 times 3 is 18 and then 3 times 2 is 6. So L is 6. L is 6 and K is 10. Okay, 7 times 1 is 7. So our answer is 10 and 6. It's D. Number 34. How many cubes are there in the figure? So we count them. 1, 2, 3, 4. 1, 2, 3. So 4 times 3 is 12. And then again 1, 2, 3, 1, 2. So 3 times 2 is 6. And then 1, 2. 1, 2, 3. 2 times 3 is 6, and then 1, 2, 1, 2. So there is 4, and then 2. So the total is 12 plus 6, 12. So this is 24, 6 is 30. So it's D. Number 35. It's a number figure relation problem. So the relation is like this. 80 minus 21 is 59. 80 minus 22 is 58. So 80 minus 14 is 66. 80 minus 20 is 60. So 80 minus 28 is our answer. It's 52. Number 36. This is a balanced problem. So these balanced problems are just like the equations. So whatever you do in the equations, you can do in these balanced problems too. So I assume that this is equal to that, and this is equal to that, and I'll sum the left-hand side of the two equations and the right-hand side of the two equations, and I'll cancel them out. So we have 1 star on the left-hand side, we have 1 star on the right-hand side. They cancel out each other. So we're left with 3 circles on the left-hand side of the balance, and we're left with 3 stars and 3 squares on the right-hand side of the balance. And in fact, what is asked here is 3 stars and 3 squares. So the answer is going to be B. Number 37. This square is folded in order and appears at the specified location. Which of the following shapes is formed when the figure is unfolded? So when you unfold it, you reverse the direction of folding. This is first, this is second. So when you unfold it to the right, what you get is this. When you unfold it to the other side, what you get is this. Everything will be reflected. So the answer is A. Number 38. This looks like a number figure relation problem. Let's see if it is so. So we have 1, 3, 5, 7, 9, 11, 13. So here it should be 15. So this is a sequence problem. It's not necessarily number figure relation. So we're done with the one relation, so we end up with 15 as the H value. So how do we find G? So to find G, I'm going to write down another sequence. So there is that 2, 4, 4, 8, 14, 22, 32, 44, and G. Okay, we need to figure out the sequence. So here is plus 2, plus 4, plus 6, so plus 8, and plus 10, plus 12, so it has to be plus 14. So 44 plus 14 must be 58. So G is 58 and our H is 15. So the summation is 73. So it's D. Number 39. This is the operation problem. Two operations are given, the triangle and the parallelogram operations. And this operation is asked. So for triangle 2 is 4 square, parallelogram 2 squares, so 16 and 4. So 16 and 4, 16 plus 4 over 16 times 4. So 20 over 16 times 4. So the answer is 5 over 16 is D. Number 40. This is also an operation problem, just like number 39. The only difference between this and number 39 is that in the number 39, the formula for each operation is given. But here, you're supposed to find the formula on your own. So the formula here is going to be, let's say this is A, this is B. So we have B minus A plus 2 is the answer. So we can write the operation like this. So here, it follows, the formula should follow every operation given here. Otherwise, it's not a correct formula. So here, 6 minus 3 is plus 2 is 5. 12 minus 5 plus 2 is 9. So 15 minus 4, 11 plus 2 is 13. That's our answer.